All right, advanced pre-calculus. Here is a pre-calculus quiz 6.4 to 6.5 warm-up to help you on your quiz. It's a lot of information there's a lot of information that you have received in a short period of time, so this is here to kind of help you out on this quiz. All right, so here's just 10 little questions, and then I'll talk about some other aspects of the quiz. You just want to be able to kind of answer these questions fairly quickly, and I think the best thing is going to be a rough sketch, unless it's fairly, a fairly straightforward question. So let's start with the first one. The graph of 2 secant 5t has a period of and an amplitude of. Okay, so let's start with our period. So let's go 2 pi over b formula. Okay, and so that's the period formula. And so period is going to be 2 pi over 5, not even any simplification to do. So that's going to be 2 pi over 5, and an amplitude of, I'm just going to look really quick and grab that 2, and then I'm going to get it wrong on the test. Okay? So remember, secant, cosecant, tangent, and cotangent do not have an amplitude. Amplitude means height, and both of those go to infinity. On the far ends, on the far, on the far upper y and the far lower y, those go to infinity. So they don't have a height. This will help for key values and the vertex of those parabola, they're not parabolas, but those parabolic shapes. That'll help on that local max and local min, but it is not an amplitude. So be careful there. That's easy to miss. The graph of y equals negative 5 sine pi t has a period of, so period is 2 pi over b. So here period is 2 pi over pi, which is 2. And an amplitude here of negative 5. Nope, got that wrong. Amplitude is always positive. Okay, so straight away be on the lookout for stuff like that if it comes up. All right, the next one, number 3, the graph of y equals negative cotangent t over 3 is a period of, okay, so this period formula is pi over b, because cotangent has a period of pi, like tangent. And so this is pi over, be careful, don't put 3 there. Remember, this is 1 over 3. All right, even though the 3's down here, it would look better if it were written 1 over 3 times t, but we're not in control of how the problem's presented to us, so we got to be able to assimilate the fact that over 3 is 1 over 3. All right, anyway, that's just 3 pi. So that's a period of 3 pi. Okay, and so asymptotes. All right, so we're going to think a little bit about cotangent. So cotangent's nice, because cotangents has the asymptotes at the beginning, and the end of the period. So they're going to be here. And you don't have to draw. I mean, I'm just kind of doing an explanation here. It's going to have asymptotes at the beginning and the end. Okay? And so since that starts at 0 for this one, then this is just going to be, first asymptote will be 3 pi. If times 1, well, the first one would be 0. So if n were 0, that would get you here. They're just going to happen every 3 pi. Now, if this were, if this were tangent, so that's that little answer. If this were tangent, you would say, you would take the half period marker, okay, and then they would go, they still are a period length. Okay, there's still a period length there for cotangent tangent, but you just have to start this one at 0. You don't have to write that. And this one you have to start at the half period. But you're still going to spin it or cycle it by 3 pi n. So I'm just going to say if, this had been tangent. You got to keep that straight in your brain. Okay, so that leads us into our next question. The domain of y equals 1/2 tan is, well, the 1/2 doesn't really do anything. So this is just one of the basics. That's pretty much in terms of domain from the parent function. all real numbers, but t can't be. So again, right, the period of tangent is pi, so the asymptote starts at the pi over 2, but repeats by pi n. And that's what happened here. 3 pi over 2, and then repeating by that period. All right, the range of negative 2 cosecant is, okay, so normal cosecant goes from negative infinity to negative 1 in union, 1 to infinity. And so if we just changed that to, if we were thinking about sine and change the amplitude to 2, it would be going between 2 and negative 2. So therefore this one will just be negative infinity to negative 2 to infinity. And I know it reflected, but none of that matters. You're just giving the range of the function overall. I mean, you could always graph that to see, but you know, we're modeling after sine. And so we're here. And here I'm just really worried about the y values. So again, you can see your 2 and above and negative 2 and below. So we write that as negative infinity to 2 bracket union bracket 2 to infinity. All right, next one on the interval pi to 3 pi over 2. Where's tangent? Concave over concave down. Tangent, okay. Tangent's easy. Okay. So tangent, we go through the origin here for the basic look. But this wants us to go on over to pi and 3 pi over 2. So we're going to go one more cycle over. So cycle, you know, the asymptotes occur at the period, half period I mean, but they occur every period. So they start at the half period, and then this is at 3 pi over 2. Pi is squeezed right in there. So here's another little wave. And so from this pi to 3 pi over 2, this is C, C, U. So again, it's just a little sketch there. You're not going to have a calculator on this. So little sketch. There's your parent. And again, rough sketch. You're not going to be graded on your sketches. These are just sketches to help your brain figure out how to answer the questions. All right, and so you just pop over, and then you can see it's CCU to there. All right, so for what values on the interval 0 to 2 pi, so that's normal, and this is sine decreasing. So plus 2, okay. So a vertical shift, intervals are x values. I'm not really worried about this. It's not going to really matter. So I could just look at sine here. Normal sine. Okay, and so I'm decreasing from the max to the min. And so this is at pi over 2. And this is at 3 pi over 2. So I'll write that a little bit. And again, rough sketches. And so pi over 2 to 3 pi over 2. Okay, so if that shifted up by 2, who cares? That whole thing would just shift up. It doesn't matter. On the x values stay the same for the decrease. This is not this graph. I haven't shifted it. But the shift, because it's vertical, does not affect this interval of decrease because those are described using x values. Okay. Cotangent function, this is a no-brainer. Odd, easy, just memorize those. Okay, on the interval 0 to 4 pi, give the ordered pair for the local minimum here. All right, so I would probably just graph this one out. So this is a period of 2 pi over 1/2, which is 4 pi, so that's good. We're looking at a normal stretched period. And then I've got amplitude. If it were sine of 2, so that's going to affect these minimums. All right, so this is 4 pi. Rough sketches, you guys. 2, negative 2. Think sine. sorry, I didn't come. I didn't list my quarter value. So like this. Okay, and so it's going to go like this. I mean, you're working fast on a quiz, so it's going to go here. And a minimum, so your eyes are good. You know, you're going to be drawn right here because that looks lower. But remember, a minimum is where the graph goes from decreasing to increase. This is a minimum, even though it looks to your brain higher. It's a minimum, and so that's going to be the ordered pair. That is going to be pi and 2. All right. Last piece here. Find the equation of the tangent function that has vertical asymptotes here and passes through this point. All right. So vertical asymptotes at plus 2 pi and minus 2 pi. So I'm just going to kind of go. All right. So that's a period of 4 pi. Because asymptotes on tangent and cotangent occur every period. And then tangent starts them at the half period, if you will. All right, and then it passes to the point pi negative 2. So pi negative 2. All right, so this is interesting. Okay, so to make this work, I'm going to have to go like this, which really looks more like cotangent, but it said tangent function, so this is just negative. Negative tan, which now looks like cosine, cotan, and then my b value. So, wow, we have been stretched quite a bit here. We've been stretched by original 4. Original pi. We've been stretched by 4, so that's going to come in at 1/4. All right, you can always do period over b is equal to 4 pi. Remember from geometry how you could just switch these. B is 1/4. Okay, so this isn't all that's on the quiz. This is just those kind of fast problems that you want to be able to answer. They're confusing if you get overwhelmed by them, but if you just practice this page and try them again on your own, like if you've watched this video, then just maybe print out a fresh sheet and try them again on your own. That will work. Now, I want to bring up the fact that I don't, in case you were zoned out in class, on the test, this was missed quite a bit. I think this was the problem. What does this equal? What is this value here? And so what you want to do is, basically, this is a monomial, so the square of the square can go to both of these, so 9/4 sine square root of x plus 9/4 cosine square root of x. Factor out that 9/4. Okay, and then what does that equal? There's your Pythagorean identity of 1. This is just 9/4. Okay, so this is just something that needs to be addressed for quite a few of you on that test. And I know it's new and you haven't seen it, but this is super easy. Just keep this in mind and just use your kind of algorithms here with exponents and your knowledge from semester 1. The other thing is to study those, how to graph. You're going to have to graph. Not all 6, but any of the 6. With transformations. Okay, and you're going to have to give, exact or all values for a particular situation. Okay, so for example, cosine of t being 1/2. You would have to give that answer. And we did a ton of these in the notes, so study your notes. So for this one, you would give a pi over 3 here, and then if you look at your look at the interval where they're looking at, so you'd give a 60-degree angle, you'd give pi over 3, and then you'd give the other positive over 3. Right, so you'd go to that 5 pi over 3 if you were just an interval of 0 to 2 pi. And then if you had to give all values, you'd have to cycle both of those by 2 pi over n. So you have to go pi over 3 plus 2 pi over n, 5 pi over 3 over plus 2 pi over n. I'm not going to go into all that. They have tons of examples, so I'm telling you to study your notes, graph any of the 6, and do that exact or all values. There's those little ones under each one of the graphs. And then the other thing is, be able to describe relationships. What is the relationship of angle t, say for tangent, as you go from pi to 3 pi over 2, right? So as t goes from pi to 3 pi over 2, what does tangent do? So what's the value there? And you could just think unit circle. So at pi, tangent is 0, and at 3 pi over 2, it's undefined. So you would write, as we go from pi, it might even say quadrant 3. You'd say, well, t goes from pi to 3 pi over 2, and tan of t goes from 0 to undefined. All right, so that's all the help I can give you. Good luck studying, and we'll see you guys soon. Take care.